Hello, Math 3 people. Today we want to graph a cubic function using transformations. What the graph you see in front of you is called a cubic function, and the parent function looks like this, y equals x cubed. As you can see, that your domain will go from negative infinity to positive infinity because it has all values from negative infinity to positive infinity, all x values. Your range similarly also goes from negative infinity to positive infinity. This function, the y equals x cubed function, is increasing on its domain. So it's increasing from negative infinity to infinity. And when we transform it, it may look similar to what we've done in the past. When we transform it, it's going to look like f of x is equal to x minus h cubed plus k. That should be a form that you're familiar with. Even though hk is not a vertex in this case, h will represent units moved left and right. And k represents units moved up and down. And this is the same thing that we did when we did absolute value and when we did quadratics. The number of solutions, the number of possible solutions for a cubic function is 3. However, when we look at this one, it only has one solution. Remember, solutions is where it crosses x-axis, where it crosses the x-axis. Okay, so here are some different possibilities for a cubic function. It could have 3 solutions. Notice it's crossing the x-axis in 3 places. It could have 1 solution. Notice it's only crossing the x-axis in 1 place. It could have only 2 solutions. It's crossing here and here, so it could have 2 solutions. A cubic function must have at least 1 solution and cannot have more than 3. So let's look at how we would describe the transformation, recalling what we did with quadratic and absolute value functions. So remember, what's inside the parenthesis always lies to us. So this minus 2 will actually move the function 2 units to the right. And this negative 4 is going to move it 4 units down because it's negative. The negative on the other side will reflect it across the x-axis. And this 2 would be a vertical stretch. Okay, so what I would suggest that you do is pause the video and do the next 2 problems. If you can't tell me the transformation, you can graph it to check your answer, but just see if by looking at it you can't tell me the transformation. Okay, boys and girls, welcome back. So remember, what's inside the parenthesis will move it left or right. So this will move it left 4 units, and the plus 1 will move it up 1 unit. We have 3 transformations in the second one. The negative reflects it across the x-axis. The minus 5 inside the parenthesis will move it right 5. And the minus 6 will move it down 6 units. Okay? And we'll practice that some more for homework. Now, what you're given here is an example of a cubic function, and I'm asking you, what is the transformation? Now, remember, in a normal cubic function, this part here is normally at the origin, so it would normally look like that. So how much did I move it to the left or to the right? It moved one, well, this is 2, so this is 2 units right, and that looks like it would be -1 unit down. So if I were to write an equation for this, it would be y is equal to x minus 2 and 1 unit down minus 1. Okay? So looking at the next one, remember, it normally, that little inflection point would be at 0. So that inflection point moved 4 units right. And it's still on the x-axis, so it didn't move any units down. So this would be y is equal to x minus 4 cubed. Okay? Again, it normally would look like this. Okay? So what did I do to this one? Notice my end behavior has changed. So I can see that I reflected it over the x-axis. And then I moved it up 2. So the reflection over the x-axis would be that negative in front, x. And since I didn't move it left or right, this would be x minus 0. And I moved it up 2 units. So this would be negative x cubed plus 2. Okay, so that's it for graphing cubic function. There's a Desmos activity in Google Classroom that I would suggest you try. Okay, boys and girls.